everybody, from your favorite artist electronist, Mr. Q12. So what I have here, it's an interesting subject, one that I'm thinking of it for some time. I never started to do anything about it, but is in plan, and as a subject in itself is worth a movie about it because it's a very interesting subject and you will like it, and I bet you will. There are two major types of memory. Volatile, which I'm having here. Volatile, it means that it needs some power. You need to power this memory, 1-bit memory that I'm having right here. And when I'm taking out the power, it forgets, it is resetting everything back to its default state. And there is another type of memory, persistent memory or non-volatile. And as the name suggests, when you cut the power, it still retains the data, and when you power it again, it is still booting up with the last sequential of bits that you stored in it. But it is not the case with this volatile example that I'm having here. There is an entire history you can read on about these two types of memory. There are actually more types of volatile memories inside this. This is the main group, volatile, but it has many other sub divisions for volatile, like RAM, SRAM. You have to dig into this subject yourself to find and to learn about all these subcategories. What I'm having here is 1 bit, exactly 1 bit of memory, but as the name I already mentioned, it is volatile. It is losing all the data when I'm resetting the device. As you can see, is turning back when I'm cutting the power, and when I'm powering it back again, is resetting to its default from the factory state, pretty much. And if I want to store bit 1, when I'm powering the device, if I'm doing this, I'm unpowering and I'm powering it back again, you see it didn't retain that 1 bit stored. Either this is 0 and this is 1. Okay, so I'm using this flip-flop. This flip-flop is actually, this chip is having 2 flip-flops, so 2 bits inside it. So you can store 2 bits, and you can actually make a complementary bit using the 2 outputs. One output is on while the other is inversed, is off, and when you switch, the other becomes on. So you can make a flip-flop here on these 2 outputs. So you kind of use this function in a very clever way, a specific clever way. So now what I'm having here, I'm using only 1 single flip-flop from this chip. The other one, all the pins are not set up. As you can see, you have to create a setting for this chip to properly function. And the setting is to put these 2 pins to positive and this pin 4 and pin 7 to the negative rail, as you can see here. And this is the setup. And if you don't set up it, prepare it, program it, this is like programming it. If you don't program it correctly, it will not make this function. It will not function correctly. This LED represents when the bit is on, just to visualize it, to show it. And when I'm turning it off, it means 0 logic. When I'm turning it on, it represents 1 logic. It's only for visualizing that is happening, that something is happening on that output pin that I'm having there. I wanted to show you what kind of memory this is. And what I'm saying is memory, it means that it can retain its data, its bit, in a certain state indefinitely, as long as it is having the power connected to it. So if you power it for 100 years, it will retain this bit in high state for 100 years. That's the idea. That's why we are calling it a memory. So, and actually the more complex memories are made from millions of flip-flops, and they are driven in a very, very complicated way. But at the very basic level, they are this arrangement that I'm having here. By the way, this is like a parenthesis. I'm using the bounced button here, because if I'm using a normal button, like this one, if I'm using it like this, it will bounce the shit out of it, and it will give me more bounced signals, and on this clock pin number 3 in this case. And this is the power rail, positive, this is the negative rail for this entire circuit, and it is using, I actually have it on its back, I've written it here. So the bounce button, and is using a NOT gate 7414. This is not a transistor, what you are seeing here. This black dot component that you are seeing there is not a transistor. It is a 1 single gate in SMD size. And the gate is called 7414. And that's what is, this is the only purpose for that gate, to Schmidt trigger this button when it's to cut any other bouncings, and to deliver only a straight, very clean on or off, indifferent of how many bounces is making this very old and very used button that I'm having here, purposely. So let me connect it back. So now when I'm pressing, indifferent how many bounces is making this button, it is the chip will filter any bouncing, and it will deliver only 1 single pulse. And that's the role of this entire circuit that I'm having here. And I'm having a capacitor here as well, and a resistor there. and here a resistor there, and this is the LED, the blue LED that you can see it, which is a very shitty LED when you have to solder it, but it's a very bright and very cool, very nice, sharp light from it, but it's very shitty to solder it, extremely shitty. So this is how it's functioning. So this is the, and I'm closing the parenthesis for this specific circuit that I'm having here, that I'm using. It's only to deliver a very clean clock pulse. That's what I'm using here. All right, so like I already mentioned, that this is volatile memory, type of memory. So I'll put it away somewhere there, and now I'll talk about my idea that I'm thinking for a very long time, actually, from when I was an adolescent, in the high school even, and I was thinking on these problems after I read some books, very light books. They were not in depth, they were not very serious books, but they give me some ideas, and even after the faculty, after the internet become a thing, after that reading other circuits, other explanations, other discussions, I started to think about it more and more. And what it is the most interesting thing, and I didn't do too much research about this subject, unfortunately. I'm not completely sure at this current hour and date if there are such persistent memories or non-volatile memories to buy, but I never find a very easy to use non-volatile memory, like a single chip like this, like a logic chip, which this means a persistent memory. When I'm cutting off the power to actually retain the information, when I'm putting back the power, it will have that information already stored. And in this case, what I'm having here in this example is only 1 bit, but what I'm imagining, maybe it is possible with such many pins that I'm having there to store even more bits, like 1 bit per output pin. So one chip like this is having 16 pins, this example that I'm having here. So I can easily have, I don't know, 12 or even 14 outputs and bits also. And you can make the chip larger with 18 or 20 pins, and have a 16 pins output with persistent memory. Each bit from that 16 bits that is storing to actually maintain its data after you cut the power off, and then put it back when you put it back to retain the sequence of bits that is already stored in it. That's why it's called persistent. And I never seen or such a chip like that. And if there are in existence, most probably they are extremely expensive and not as cheap as I'm not sure, 100 pieces for $2 or $1 as these logic chips are. So that's a shame on humanity, because they didn't thought of it. I have to think of it, and I have to expose the humanity for being lazy, not being serious. So there is an entire history about non-volatile or persistent memory progress on this direction of volatile. But imagine if they were progressing on persistent memories, and if they were concentrating on it a little bit more harder. From some articles, I've read about some specific materials that are retaining some electrons. And if you are, depending how you are powering, different levels of voltage, voltage dependent. If you power it with less than 2 volts, you get a 0, and if you power it with higher than 2 volts up to 5 volts, you get a 1 state bit. It is a persistent memory. If you cut the power, that material inside will retain that bit information that you program it with. But that's very advanced, and probably it's only in the domain of laboratory experiments and stuff like that. And with the mortals, we don't have that access, or me personally, I don't have that connections or that money. And my idea how to actually make an actual persistent memory with what I'm having, I'm thinking on a very interesting and very cheap way of doing it. Well, relatively cheap, because as you can see here, I have some motors, very small motors. These are actually vibrating motors, and these are used in cellulars, in mobile phones. When the mobile phone is vibrating, is using this type of motors that I'm having here exposed. And I managed to take out to this ensemble. This is how it's looking actually. This is having a sticky glue here, and here is a piece of rubber, and I took out this is like a lid, and I took it out. And here probably you cannot see it very well, but it's like a V. You see my tip is entering there inside, so it's like a V. And in that V hole that I'm having, it was this little piece of metal, which is a piece of iron probably, and it was there as a weight imbalance. And when this is rotating, because of this weight imbalance, it is vibrating quite seriously. Let me actually show you because it's good to see it. I'm having it right now at 5 volts because I powered that circuit, but I have to lower it down to 3 volts only for the motor alone. So now, and as you can see, it is bouncing around, and it is vibrating quite seriously. And this guy here, it will not do the same thing as that, but it will do something. Unfortunately, it's not working right away, but it needs a little bit of pressure. I'm not completely sure. The contacts is actually having some contacts here. Let me show you. They are very extremely tiny there and there. There are two brushes like this, and those brushes are lifting up this very light element. Here is the commutator of the motor. It's having some cutted lines. It's not a perfect circle here, and it's having 6 elements for the commutator, for the brushes. And because those brushes are like little springs, is lifting up this very light element, and you have to press it a little bit to make the contact. But press it in the way, okay, that is not, yeah, you see, it is like that, and it is working quite okay. This, on the other hand, are a bit. This is without the head. This is its head here, and let me show you. I'm not sure why this is with polarity. Usually, a motor doesn't have a polarity, so I never use them. As you can see, you can probably even hear it. All right, and I managed to take out this weight. This is a press fit weight on the axle of the motor, and it is at a very low tolerance, so it's press fit very well. And I'm not sure if I can put it back, but it is possible to modify these two types of motors. That's why I'm showing them here. So it is possible to modify them with a little bit of patience and not damaging them, you know. And theoretically, what I'm thinking is a mechanical type of memory. So this is the way I would make it personally, if I was to store without power a couple of bits of information. I don't need that many bits, but sometimes I will need a couple of them. Like, I'm not sure, maybe 4 bits, maybe 8 bits, maybe 16 bits. Most probably I will not need 32 because they are quite many to build it from this 16. It's a bit of a stretch of how many I will need in a practical way. But 8 bits, I believe it's a good number for the devices, for how many devices I'm having and I can use. So what I'm thinking is something like on-off toggle. So this is the axle of the motor. This is the motor, and here is a stop. Here is a stop. So here, stop element, whatever it is. And when this axle is going here in this direction, when I'm powering like this is the wire. This is the wire of the motor. And when I'm putting positive and negative, from this state here, it will rotate and it will arrive at this point here. And when I'm inversing the polarity, when I'm putting here positive and here negative, it will go back into this other side here. So pretty much it will change state from one side to another. And on this little arm, I can make it. I can either put an obstructive element here, or a piece of paper or a piece of plastic, but ideally very light, and I can stick it to the axle that is rotating, and somewhere here it will be an LED, and on top of it it will be an LDR, light dependent resistor, and when this obstructing element will come between them here, it will interrupt the light, and the LDR will signal that is 0 or 1. So pretty much that's the idea of creating a persistent memory. But the problem is with vibrations. And if I'm vibrating this element will jump from its position there. So most probably I will need a third element, like a electromagnet. It's basically a relay with a bobbin here. And inside is having a hole. And here is a iron that is moving left and right. So it's creating a linear movement like this and like this, left and right. So this kind of element can put an obstacle between this state here and this state here. So this is when it's 0, and this is when it's 1. When this is rotated in this side here, if we are splitting in half, when this element is in this side here, it will represent a 1, and when it's in this side here, it will represent a 0. Of course, this splitting element here, it will be a bit more larger, most probably like a semicircle, like something like this probably. And when it will rotate one side and then the other side, and it will signal very efficiently when it's on and off. And this will be like a brake. It will lower down. So imagine this is a spring here, and this is a little like a little element that is stopping this larger disk from getting on one side or another. So so this is the disk here when it's on zero state here, like this, or in this other side, or in this other side when it's here, pretty much. And it is stopped by this element. And when I'm starting to transmit the data, which it will be in a brief time, in a couple of milliseconds actually, it will be quite brief, quite rapidly. So this electromagnet will retract this stopping element. It will be compressed by this spring here, and it will. So step one. So step one, LMAT electromagnet, LMAT retract. Step two, switch bits, either 0 or 1. And step 3, LMAT electromagnet release. So it will retract all the 8. If I'm building 8 bits with 8 motors like this, it will be on the same line, all these stopping elements, and all of them will be lifted up at once, and it will leave space for this to rotate left or right. Depends how I'm sending the signal, and after I'm sending the signal, if it's 0 or 1, then I will release this electromagnet, and when I'm releasing it, all the blocking pins at once will come back, and securing this disk either in its proper position, in its programmed position, pretty much. And how to actually drive all these motors? I believe because they are working at 3 volts, as you can see here, at 3 volts and there, the voltage is quite low, and I don't actually need to spin continuously. I only need a few milliseconds of spinning, maybe 1 second, of spinning, but it will not take 1 second because it will be less than 1 second. So all these motors will have to rotate, to be powered, rotating, and then when we'll hit this stopping element here on the bottom, it will stall, and it will pretty much short these windings, and it will hit up. But if you leave it for a very long period of time like that, for a very brief time, it is perfectly acceptable to make this trick that I'm having here, and to actually keep it in power a tiny fraction of a second, maybe 1 second. But I'm assuring you, it will be less than 1 second as it is stalling on that position. Depends how the signal is transmitted, if it's one by one or all at once. Depends. I will see how well this will be made. If I will actually make it, because right now I'm discussing a concept. I'm not completely sure if I will actually make it in reality, but it is my dream for a very long time actually. So instead of electronic memory retention or bit retention, it will not be electronic but mechanical memory retention for a persistent memory. So that's how I will drive it. I believe with any kind of logic chip, it will be good enough, I believe, on its output. So if I'm using a flip-flop, either this or this, as you can see, when this is positive, I told you in the beginning of the movie, this is good as a flip-flop. When this is positive, this is negative, because it is having actually a NOT gate for this knotted output. This is an output that is having a NOT gate inside here, the construction of the flip-flop. And when this is positive, this is negative. When it's reversing, when this is negative, this is becoming positive. So it is flipping the polarity pretty much. It's flip-flopping like that. And it is perfect for this kind of miniature motor that I'm having here, and probably that one's as well. And this is with a flip-flop, but with any kind of logic circuitry, or even with a counter, most probably, if I'm having a counter, I can count through each, probably. I didn't put too much thought on it. I only thought at a certain level what to do. And I didn't go into this project too deep to actually resolve too many problems. But for sure, there will be a lot of problems to resolve. And in the end, I believe it will be a very interesting, very interesting device element, memory element, at least. And I hope it will give some ideas to China and to the Germans, to Germany, and to Russia. I'm not sure about America, but these 3 giants of productivity in modern world, especially in electronic devices, I hope I can influence them in developing and researching a very easy, very stupid easy persistence memory chip or device, like I'm planning here. And I will do my best Not right now because I have another projects to finish first, but after them it is in plan. This little thing that I'm having here is in plan to at least start it. If I will not be able to complete it 100%, to have a good result from it as I'm imagining it, well, at least I will try it. And other more smarter, no, not actually smarter, but more resourceful people might make it work for me or for everybody to be able to replicate it in a do-it-yourself environment, like in your home, like I am right now myself. So this is the discussion about. Of course, there are many other ways, possible ways, but this is the most practical way I personally could think of to create a persistent or non-volatile memory element. In my case, element. It will not be an integrated circuit because I don't have the resources to make, or the knowledge to make it into a chip. But it will be very cool to have a very straightforward, very easy to implement, extremely easy to use, very low bit count chip for a persistent memory. That will be extraordinarily important for electronics in general, I believe. It will be very cool to have in the arsenal of humanity. You know. So that's it. This is it. Thank you very much for listening, for watching, and I hope it will give you some ideas and some dreams that you can think and dream yourself onto it from now on. I hope you like my subject. Thank you very much for watching and for listening, and see you later from your favorite artist electronist, Mr. Q12. Bye bye.